Hello, greetings to you all around the world. First and foremost, I'd like to take this opportunity and thank the president of CTB International, Mr. Marvel Mtembu. Thank you for inviting me to share knowledge with the young people around the world. And the vice president, Mr. Victor, thank you so much for this platform. Thank you for what you are doing for the young people. And today we'll be looking into um, a bit of mathematics, how we can help those of you that will be writing exams, since it's year end. And if you have any questions, you'll send them through to our link and to our email. The information will be right on the screen. So let's start without any waste of time. Mathematics is very easy, and although many believe that it's a difficult subject, no, what you need to do, you need to have passion for it, because if you have passion for something, really, you will do anything and everything to make sure that you understand. It's all about understanding the basics, understanding the principles, the rules and laws behind mathematics, and you will get it. So when you write, especially those that are doing metric in our country is actually the last class before university, and we call it grade 12. So when you're going to write that final examination before university, in mathematics, you have a couple of questions that they'll be giving you. And so I'll just be going through some of them. We won't, of course, do everything because we write paper one and paper two. So we won't do everything because of time. Then I'll just help you to check what you can do. Okay. So what you did in the previous classes before coming here is very important as to what you are going to need to pass this examination. So for an example, they'll give you something like this. They'll give you something like this. These are the type of questions that you will get. Okay. Say x squared minus, this is question one, of course, minus 7x plus 12 is equal to 0. And then they say solve for x. The question is solve for x. And then remember that you did what we call factorization in the previous class. Factorization, you need to know how to factorize this thing. And there are different methods of factorization. So for example, number one, we have what we call taking out a common factor. In this case, when you take out a common factor, is if you have maybe something like 2 squared minus 4x cubed plus 8x. If you have something like this, and you are required whether to solve for x or to simplify, you realize that you have the first term, second term, you have three terms in this case. In both three terms, we have something that we say it's similar or it's common. What we mean by that is that when you look at the digits, you have a 2, a 4, and an 8. And all of them, you can divide them by a 2 without getting a remainder. So we say we have a common factor. So 2 will be a common factor because it's the lowest number digit is 2. You get to the variables, you have an x squared, an x cubed, and x. So x appears in all the terms, and therefore it will be your common factor. So you will have something, you will say, okay, in the first term, if I remove 2x from there, I'll be left with an x. The second term, if I remove 2x from there, I'll be left with 2x squared. The last term, if I remove an 2x from there, I'll be left with 4. So if you take this and multiply it by each term, you will get back to this. And that simply means you got your answer correct. Okay, so that's taking out a common factor. That's one of the methods of factorization. Remember, we are doing that so that we can come and be able to answer this question here. The second one is something like this. We call it difference of two squares. So if you have something like this, they say you need to, maybe you are solving for it equal to 0. You will simply say, okay, you take the root of x, which is of x squared, which is x, and then you put x here and x here. You find out that we have a root of 16, you put a 4 here and a 4 here. If you put a negative here, put a positive here is equal to 0. You find out that if you multiply these two things together, you will get back here, simply meaning that this is correct. Okay, so that's the second method. It's called difference of two squares. And then there's another one, which is called difference of cubes. If you have something like this, difference of cubes, you take the cube root of x cubed, which is x, the cube root of 8 is 2, and then what you simply do is you square the first term here, you change the sign, and then you multiply the two terms. 2 by x is 2x. Where do I get the positive from? Remember, I said you change the sign here. And then you square the last term minus 2, square it is plus 4. By doing this, if this was equal to 0, you're solving for x, this is what we're going to do. And then you can continue with it from there, okay? And so the last method that we'll discuss here is this one here. It's called the trinomial or quadratics. When you deal with quadratics, you say you're looking for the factors of 12 that will give you minus 7. The factors of 12, we have 12 and 1. Remember, what are the factors? Factors of a number are two numbers that you multiply them together, they will give you that number. So you multiply 12 by 1, you get 12, you multiply 6 by 2, you get 12, you multiply 4 by 3, you get 12, all of them. But now you need one pair. This is 1 negative 7. How do you get negative 7? If you add or subtract the two factors. So you add or subtract the 12 and 1, you're not getting 7. You add or subtract the 2, the 6 and 2, you're not getting minus 7. If you add these two things, 4 and 15, as I was saying. Okay, let's get back to our board. All right. So as I was saying, yeah, so we had x squared minus 7x plus 12 is equal to 0. And then I said you're looking for the factors of 12 that will give you negative 7, and we found that it is negative 4 and negative 3. Okay, and then you simply say, okay, therefore x, if this equal to 0, therefore your x will be equal to 4. Remember that you transpose 4, take it to the other side, change the sign, or x is equal to positive 3. Take it to the other sign, it will also change. Take it over the equal sign, it will change the sign, okay? And then if we have something like this, that's one of the questions that you should expect. You will get something like that. Sure thing. Surely, you'll get something like that. Okay, so let's get something like this. If we have x squared minus 5, if we have x squared, okay, if we have x squared minus 5 inside the square root, and then this equals 2, and then inside the square root, maybe we have an x, and you're supposed to solve for x. Remember that when you're dealing with surds, these are surds, when you're dealing with something that you have square roots, like this, what you simply do is to square both sides. So you're simply going to square both this side and you square everything on the other side. If you square this, the square will remove the square root, therefore you'll be left with x squared minus 5 is equal to, you square the 2, you get an 4, you square this, the square root will go away, and therefore this is what you're left with. You multiply this out, this is 4x, you transpose it, this is what you're getting, x squared minus 4x minus 5 is equal to 0. And therefore, you can factorize this. The factors of 5 are x minus 5 into x plus 1 is equal to 0. And therefore, your x will be equal to positive 5, or your x will be equal to negative 1. If you take this negative 1 and or positive 5, substitute them on the original equation, you should get your left-hand side should be equal to your right-hand side, just to prove to yourself that your answers are correct. Okay. All right. Let's move to the next question quickly. We will do inequalities. We will do a question on inequalities, which is also very important in your question paper. Okay, so let's look at x squared. If we have x squared, this one, if we have x squared plus 8x plus 16 is greater than 0. This we call inequalities. What you simply do, you do the same thing. You factorize this because this is a trinomial. This is a quadratic equation. So you get the factors of 16 that give you 8, okay? So what will that be? Factors of 16, you have 8 and 2. Factors of 16, you have 4 and 4. So let's go for 4 and 4, since well, all the signs are positive. So this is x squared is equal to 0. Why did I write it this way? Because remember, this is simply x plus 4 into x plus 4. It repeats itself. So that's why, hence, I just wrote x plus 4 all squared. Okay. So if you do this, we take square root both sides. Therefore, x plus 4 is greater than 0. And therefore, x is greater than negative 4. Okay. If you take negative 4, substitute it here, surely you will get 0 on the left-hand side. Okay, so that's another question there. And then the next question that you are most likely to get is what we call simultaneous equations. And with simultaneous equations, maybe we may not do all of it, but we'll show you how to work on it. Okay. If we have, for example, if you have 3x minus y is equal to 4 as an example, and then you have maybe x squared plus 3y is equal to 8. If you're going, they say solve here, you need to solve for x and y. If you're going to do that, you need to get one equation. One of these equations have one variable on one side. But I mean, if you call this equation 1 and then you call this equation 2, you can say from equation 1, what you're going to do is to say you make y the subject of the formula. So if you take y to the other side, it will have positive y is equal to, we have 3x on the other side. If you take 4 and transpose it as well, it will be minus 4. Okay, so if you have this, you can say this will be your equation number 3. So you say substitute equation number 3 into equation number 2 into equation number 2. When you do that, you are going to find that we have x only. The only variable that will be left, that will be there, or that will be dealing with is x. You'll be able to solve for x, and from there, you simply come back because you'll be having the value or values of x. Then you come back to equation 1, and where you see x, you substitute the value of values of x that you got in the equation 1 to get the value of y. That's how you solve your inequality. And then let's move to the next topic. So this is your question 1. It's around 18 marks to 22 marks, between 16 to 22 marks. So make sure you get all of it. No reason to get 0 out of it, okay? So you get to another question. That's where you have things like your number patterns. So number patterns, if you have something like uh, something like 5, 8, 11, etc. You say, find out that, and then maybe you are asked to find the TN formula. So remember that what you are going to do is to say, okay, this is my first term, second term, third term. And then what did we add or subtract from the first term to the second term? We found out that we added 3. From this to this, we also added a 3. And since what the number that we are adding is the same, it is common, we call that number a common or constant difference. Okay, so we have a common difference. And that common difference, we normally show it with the letter D. Okay, and here we are simply meaning that since we are adding the same number, the common difference, that means we are dealing with what we call the arithmetic number pattern. Okay. Remember, we have arithmetic number patterns, we have geometric number patterns, and we have what we call quadratic number patterns that you did last year in grade 11. Okay. So in this case, you will have, remember that our Tn formula is Tn is equal to A plus N minus 1D. Okay, so what is A? A stands for your first term, T1, and then you have a D. D is the common difference there. So if you put where you see A, you put a 5, and then plus N minus 1. Where you see D, you put your 3. This is what is going to happen. What's going to happen is that you end up with your Tn formula will be Tn formula will be the 5 that we have. 3 multiplied by N will be plus 3N. 3 multiplied by negative 1 will be negative 3. So you'll get 3N. 3N, 5 minus 3 is positive 2. So this will be your formula. That will be your Tn formula. That's pretty easy and straightforward. But remember that from there, we can ask you different questions, as in like, what is your 21st term? So when you are asked what you calculate the 21st term, you simply put say T21, and then where you see N, you substitute 21. And then you put everything in the calculator and you get an answer. Of course, 3 times 21 is 63 plus 2, that will be 65. Okay. And then there's another question they can ask you to say, okay, you found your Tn formula, and then they will say, okay, let's write back this. What will be, what calculate the term that will be equal to 250, something like that. So if they say which term will be equal to 250. So what you do is where you see Tn, you put 250, and then you say it's equal to 3n plus 2. And so you solve for n. That means you transpose 2, divide by 3, and you'll be able to solve for n. Okay. So those are one of the questions that you can get. And now let's do a question on geometric sequence, because this, what we're dealing with here is arithmetic sequence. Okay. So let's look into a geometric sequence question. If you have, there's a question that I saw somewhere that I liked, that I want us to, oh, okay, before we get to geometric, let's do, let's do geometric first, and then we'll get to quadratic. Okay, so if you have a question like this, you have an x, you have an x, you have a 2, you have a 4, and then you are told that this is a metric number pattern, geometric sequence, and then you are asked to calculate the value of x. What do you do? First and foremost, you know that this is your T1, this is your T2, this is your T3. And remember that in geometric sequences, T1 over T2 must always be equal to T2 over T3. Unlike what we are doing in arithmetic number, where we expected that T2 minus T1 must be equal to T3 minus T2. So this is arithmetic sequences or arithmetic number patterns, and this is geometric. So now we are dealing with geometric number patterns, okay? So what are we going to do? We are asked to calculate the value of x, so we are simply going to say T2 all over T1 must be equal to T3 all over T2. Okay, so from here we simply cross multiply, therefore we find that 4x is equal to 4, we divide by 4, therefore your x is equal to 1. It's that simple. The question was find the value of x. And of course, from here, just like we said in arithmetic number patterns, you will get questions like what is your 17th term, or find the number of terms if your last is 300 or so. So you'll be asked different questions. And from there, it's just straightforward, okay? So this is number patterns. So these questions are pretty easy as well. I don't think it's something that you'll struggle with. So because of time, I want us to also look into there's a question on calculus. Remember that we do calculus as well in metric. And there's a question here. It says, determine f derivative of x from first principles. Okay, so yes, we have to get it from first principles. If you are given f of x is equal to 2x squared minus 3x, and you are asked to calculate the f derivative from first principles. Remember that when you're asked to calculate this from first principle, you already should know the answer. So if you are deriving this thing, what you're going to get is, you know that your answer will be 4x minus 3. So even if you are doing it from first principles, you are expecting to get this answer, okay? So it's nothing really strange. So what do you do if you're asked to calculate this from first principles? You simply say, okay, f derivative of x is equal to the limit as h approaches 0 of what? The formula says of x plus h minus f of x all over h. Okay, so this is the formula that you use. And then you take this, substitute it here, and then what are you going to get? You're going to get 2, where you see x, you put this, x plus h all squared minus 3x, and then minus 2x squared minus 3x all over h. Of course, as the limit approaches 0, you don't forget this out, okay? So you square this, you multiply this out, you're going to get x squared plus 2xh plus h squared minus 3x minus 2x squared plus 3x, everything over h. The limit as h approaches 0, okay? So what do you have? You have x squared here. We have the last term is plus 3x. We have negative 3x. So this negative 3x will cancel the positive 3x, okay? And so what are we left with? Okay, we have minus 2x squared here, and then we have positive x here. So we are going to be left with, let's just erase this so to create space. So you'll be left with negative just a moment. Not sure if I think we made a mistake somewhere here. Yes, we made a mistake somewhere. It's something we didn't take into consideration. Remember that the question was 2x squared minus 3x. So we left out this 2, which is this 2 here. We didn't bring it down. So we are supposed to have 2x squared here, and then 4xh here, and then 2xh here. Okay. Yes. So let's go with it. And then that means if we continue, you're going to be left with, we have 2x. That means the 2x squared positive will cancel 2x squared negative. So we'll be left with the limit as h approach 0 of 4xh plus 2h squared. Okay, all over h. We have if we take out a common factor of h, we'll be left with h into 4x plus 2h, everything over h. The h will cancel the h, and then as the limit as h approaches 0, this will approach 0. We left something again, I think. We left something somewhere. This. Yes. All right, so this will approach 0. The 2h will approach 0, and then this here is supposed to be 6x. This here is supposed to be 6x multiplied by this 2. And that means 6x minus this will supposed to be having minus 3x here. Okay. Yep. Yebo. Let me correct that. I'm not seeing my handwriting again. Let me just correct that and let's get to it again quickly. Quickly. Writing. Quick. All right. I think the question we had, yeah. So we had 2x squared minus 3x. Yeah. So I said that you substitute, you get x plus h all squared multiplied by 2. The limit as h approaches 0, and then minus 3x. Okay. The 3x here, this is where we made a mistake. Where we see x, we put, this is where we made a mistake, x plus h. Okay. And then minus, 2x squared minus 3x. So that's why we made a mistake. Okay, so we'll just do it quickly, run through it quickly again. So this will be 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus 2x squared plus 3x. Everything all over h. Okay, so the 3x will cancel the 3x, and then the 2x squared will cancel the 2x squared, and then we will be left with 4xh plus 2h squared minus 3h, everything over h. Okay, so let's finish it quickly. So all over h, and then if you take h as a common factor, h, the limit, this will be the limit as h approaches 0, or if we take out h as a common factor, we'll be left with 4x plus 2h minus 3, everything over h. It will cancel the h on top there, and then as the limit as h approaches 0, this will approach 0, and then we'll be left with 4x minus 3, and that's what we're expecting to get. Awesome. All right, so that's how to get the derivative from first principles. Okay, the derivative of x from first principles. It can be a long one, but just make sure, or like I said, you should be expecting what to get as an answer. So it's not really a big deal. Okay. So let's get the last question on this paper, and then we will get to do maybe a bit of paper two if we still have time. So if we are asked to calculate, to find the derivative of this cube root of x over 2 and then 1 over 2x. Okay, if we have cube root of cube root of x over 2. Okay, where is my eraser? If you have the cube root of x over 2 plus 1 over 3x, this all squared. And then you are asked to calculate to find dy dx. Okay, the first and foremost, you can't find dy dx when you have your square root here, and you need to square this as well. So you need to write it in standard form. So you will say, therefore, is equal to, you remove the cube root here, and then you find that x 1 over 3 all over 2 plus, if you square this, you get 1 over 9, because 1 squared is still 1, 3 squared is 9, and then you square this. And then remember, you cannot derive as long as your variable is a denominator. You need to take it up. So it is a, it becomes a numerator. So let's write that again. Let's rewrite that, and then this will be is equal to x 1/3 over 2 plus, when we take the x up, it will change its sign all over 9. So that's what we have. Now we can derive this. It's in standard form. We can derive it, okay? Therefore, we say dy dx, or f derivative, dy dx will be equal to, you derive this, you get 1 over 3x exponent 2 thirds. Remember that you subtract 1 from there. Okay, that's where I got 2 thirds. Minus, and then you multiply this by this, you get minus 2x minus 3, everything over 9. You write it, you rewrite it properly. That's what you get, 1 over 3 cube root of x squared minus 2 on top all over 9x cubed. So this will be your final answer. That's what were we doing? As to find the derivative of the question that I wrote up. Okay, let's move to something different, something new when you're writing your paper two. Of course, we didn't look into, because of time, we didn't look into things like your financial mathematics. We didn't look into things like your functions, where you have your parabolic functions, your hyperbolas, your exponential functions. And yeah, those will need a lot of time to discuss. Okay, so just a moment, and then we'll be right back. Prophet, how far are we with time? Victor, President, how far are we doing with time, guys? Can we?
Okay. I'm not so sure because this Zoom thing doesn't show the time, but if you are close to finishing, how many? Okay, what's left on your agenda?
I just wanted to discuss maybe one more question, and then I'm not sure how long it will take. Let me see if we can. It's not long. We can do it. And
yeah, because with the
okay,
time
let me
is,
just do.
yeah, the time is yours. You're the
Yeah.
one who will know, because already I feel like, yeah, not to say you've taken much time, but
Yeah.
it's
Yeah,
you know, it's not like maybe
shouldn't be
thing.
too long. Yeah.
Yeah. Maybe if you can, like the topic which you want to cover, we can take that one, and then maybe afterwards we can close, and then maybe you will see if possible we can have class 2 if need
That's
be.
what I'm thinking. That's what I'm thinking. I'm thinking let's do class 2 where we can discuss some of these questions, paper 2 in details, and then trying to just do it quick. Yeah.
Okay, so what do you think? You wanna do the last topic or?
Yeah, let me see if I can get the graphs here quickly. And we can do something. All right, so yeah, let me do the last question and then.
All right, sir. Yeah, I know you can shoot anytime when you're ready, and then we'll just try to erase this particular segment. But I like the way you said it. We'll be back. We'll see what we can, do about it. Look like it's a proper show. You've been you've been in the TV for long. All right, let me.
Yeah. All right.
Sure. Maybe we can start, with welcoming back. Welcome back from the short break, and then you go on.
Yes.
All right. Thank you, sir.
Welcome back. I hope you took a glass of water, and let's continue. We were still dealing with our paper 1, and we will do just one more question. Then we will meet again next time to discuss paper 2. Because of time, we won't do paper 2. Okay. So I want us to look into another question that we left out. I wanted to talk about the quadratic equations, quadratic number patterns. Okay. Quadratic number patterns. So let's shoot straight into it. Let's get straight into it. If we have something like find the Tn formula for the quadratic number, the Tn formula, and we're given 5. If we're given 5, we're given 4, and then you're given negative 19. Okay. So what I asked, you asked first and foremost to calculate the constant second difference, first and foremost, the constant second difference. From there, the second question, maybe they will say determine the Tn formula of the number pattern. Okay. So if you're asked to calculate, remember that when you're dealing with quadratic number patterns, normally you will find that if you find the first difference between this and this, you want to find out from the first term to the second term, what did you add to get minus 4? So surely you added or you subtracted negative 9 from here to the second term. Okay? And then from here to here, surely you added a negative 15. Okay. Now they can ask you, oh, okay, so let's continue and then we'll get to that. So this, let's add another